Okay, so now I'd like to go ahead and do part 2 of lesson 3.4 and talk a little bit more about some of the things that these inverse functions have. I'll go ahead and do part 3 tomorrow. So we'll just do this step by step, and I think what we'll do is we'll skip the study guide for this. It didn't look as useful to me as they usually are, so we'll basically work on the book assignment. And so as we get into examples, I'm going to go ahead and do more book examples, so that should help you get through the homework assignment. So anyhow, let's take a look at things. Yesterday we were talking about, and one of the facts we said, well, one of the ways to test to see if you have an inverse, you start out with two functions, an f of x and a g of x. And if you put g of x inside of f of x, like we did in section 3.3, and we get a result where this is equal to x, then the only way that's possible is if these two functions are inverses of each other. So that's a quick test of doing that. And likewise, you can do it the other way around. If you do g of f of x, you should get x also. And it's very similar to those examples I was trying to show you yesterday. X squared, you can think as the inside function here. The outside function, or the one that you're putting it into, is maybe the square root of x. So f of x, for example, in this case, would be equal to square root of x, and g of x in this case would be equal to x squared. So f of g of x, what we do is just basically put this function in there. And when you do that, they cancel. And so you get this equals x. Well, the only way that can happen is if these are inverse functions. And we've already discussed this. X squared and its square root are inverses. Well, so anyhow, I'm going to go ahead and do a couple other examples from your book that will illustrate the same idea. So let's just go to your book. You're going to be doing 15 through 25 odd now on your assignment. So maybe I could just do a couple of examples here for you. Let's look at number 16, for example. I think I'll snip this one. There's my capture. There we go. Capture this one. Make this a little bit bigger. Okay. So to verify that these are inverses, what we do is we put g of x inside of f of x, and then we do it the other way around and show that you get x. So f of g of x. We're trying to show that that's going to be equal to x. Since we don't know it is equal to x yet, we'll just put a question mark there. Okay, so as you get better at doing this, let's see. All you need to do is take this part, okay, and put it in here. Okay. So the way I've been doing this, I want to kind of show you how I do it. I like to write out f of x. Okay, so f of x, start out by just writing f of x. It's 2x plus 3. So again, whatever's here goes in here. So f of g of x then, if you want whatever's here, okay, let's write it out again. 2x plus 3. Whatever's here goes here. You see? That's why I'm saying you take this and shove it in there, right there. Okay? So anyhow, what would that look like? Well, we'd have 2 times whatever x is, and then we're going to add 3 to it. Well, in this case, this is where the g of x comes in, right there. So we're going to put 1/2 x minus 3/2. Well, when we distribute this 2 here, 2 times 1/2, of course, is 1. And you're multiplying by x here, so that's just 1x, or just simply x. When you multiply by here, you would have, let's just do this little calculation out here. You'd have 2 times negative 3/2. Well, in this case, the 2 cancels off here, and so you end up getting negative 3. And of course, there's a plus 3 here, so those subtract off. And so this, of course, is just equal to x. Now, on these verify problems, you have to do it both ways. So it's a little bit extra work, but you need to show g of f of x also is equal to x. So I'll do that next. We'll continue this way. And now what we'll do is g of f of x. Now, again, what is g of x? Well, that's 1/2 x minus 3/2. And so whatever's here goes in over here. Well, in this case, f of x is right here. F of x is equal to this. So what we're going to do is shove that in right here. So in this case, we get 1/2 times something right here. And then we're going to subtract 3/2. Well, the thing that's going again is this 2x plus 3. So we're going to put a 2x plus 3. Well, this time when we distribute 1/2 times 2x, 1/2 of 2, of course, is just 1. And then you have this x here, so you get x. And then you have 1/2 times 3. Well, that's a positive 3/2. And then, of course, you subtract 3/2 here. And so those subtract. And so this also is equal to x. So this phenomena where you put one function inside of another and you get x only happens if the functions are inverses. And so that's what you have to do on these kind of problems. You just have to verify, do simple little steps here, and show that you end up getting x. If you don't get x, then they're not inverses. So that's pretty cool. So anyhow, those problems are very similar. You just plug them in, see what you get. So now let's move on to this type of problem here. Inverses of power functions. Okay. So you're going to be doing the odd problem. So I think what I'll do is I'll do numbers 22 and number 24. And I think that'll help you get through these odd problems up through 27. So how about if I capture those real quick? Let's see, my tools, go to capture, partial, and we'll do a couple of these now. Make this just a little bit bigger. Okay. Okay, so let's say we're doing 22. We have f of x is equal to x to the 7th power. We're just finding the inverse. Well, the trick that we learned is just to switch variables. So we're going to switch variables. Now this normally is y right here. F of x is equal to y. So what we're going to do is switch variables. We're going to put x here. We're going to say this is equal to y to the 7th power. Now what we want to do is solve for y. Well, how do you get rid of this 7 here? Well, the inverse operation of a power is its root. So you're going to do the nth root on both sides. So I want to do the nth root, in this case the 7th root, In this case, I'll do a 7th root, and then these will cancel. And so I get y is equal to the 7th root of x. Okay, it's a 7. And now the idea is that you call this isn't really equal to y, because y is really equal to x to the 7th power. But this is the method we use to find the inverse. Just all we do now is just write this as the inverse function. Okay? And that's the method you use to find the inverse. It's a 7 now. By the way, just keep this in mind. Sometimes the book will write this in this rational form, as like a fraction. This is equivalent to x to the 1/7 power is equal to f minus 1 of x. So that's how you could do that. Anyhow, let's try maybe 24. A little bit different problem here. This time we have f of x is equal to -10 x to the 6th power. And notice we have a domain restriction this time. X is less than or equal to 0. This is to the 6th power, whatever number you plug in x there. And if you put in negative numbers when it's to the 6th power, that's automatically going to be a positive number. That's automatically going to be, that portion is automatically positive, even though x is negative. So we have a -10 here. Let's see what happens when we switch the variables this time. So if I put an x here, and I have -10 y to the 6th power, what I want to do is solve for y. So I think what I'll do is, I'm just going to use a different color here. I'm going to divide by -10 here, and I'm going to divide by -10 here. And so when I do that, I get x divided by -10 is equal to y to the 6th power. Now, is it starting to make sense why this had to be x is less than 0? It's because, like, take a look here. This has to be like a negative number to cancel out that negative. Otherwise, we cannot take the 6th root on both sides. Okay? Because this is y times y times y times y times y times y. And since there's an even number of y's here, when you multiply these out, whether it's positive or negative, this will always come out as a positive number on this side. So the only way to make that work is to make that one a negative, because then that negative will cancel out that negative. And so this side will be positive. Does that make sense? So that allows us to take the 6th root then. If I take the 6th root over here, and I do the 6th root over here, this will cancel off with this, and we will have our inverse function. X divided by -10. And again, the only way to do this is if I allow the domain to be less than 0. And that will make x a negative number. Of course, if it is 0, I'd have 0 divided by -10, which of course is just 0. And the 6th root of 0 would be 0. So we're allowed to have 0 there. Anyhow, that's what we'd call y. And again, just to remind you, we only call it y temporarily. At the very last step, we want to change it back and write it as the inverse. And it's just a method we use to find the inverse function. It's a nice convenient way to do that. So this would be the inverse function now. And we'd have to have this little restriction right here as a part of our domain. That was the domain for the function, and in this case it's the domain for the inverse function as well. So anyhow, there's a couple examples we've done. Just keep in mind that sometimes they will write this as a fractional exponent. So they might write this as x over 10, negative 10 like this, and they might write this to the 1/6 power. That's equivalent. Those are equivalent answers. So there you have it. I think we have enough examples to get you through the next portion of the assignment. So what I'd like you to do now is 15 to 25 odd, and then do 26 and 27. And then we'll just stop right there. The last portion I'll cover in part 3.